Sorry. Okay, so I just wrote down the formula there. So we don't know the frequency in this one. We do know the length. The length is 4, so we can do 2 times 4. And the square root of T, the tension, we know is 400. Now, mu. So in this one, it says the mass is 0.04. Doesn't say the mass of 1 meter, or just see the way up here it was kilograms per meter. So what they're telling us there, without kind of using so many words, is that the mass of 4 meters is 0.04 kilograms. And we want mu, and mu is the mass of 1 meter. So if 4 meters is 0.04 kilograms, then 1 meter is going to be 0.01 kilograms. And that's what will go in here, 0.01. Okay, so then we type that all in. So there's no rearranging here, so it should be easy enough. 400 over 0.01. So that gives me a frequency of 25 hertz. Okay, so that's 2 and 4. So question 5. A string on a guitar gives out a note of a certain frequency. By how much must the tension in the string be increased if it is to give a note of twice the frequency, its length remains the same? Okay, so this is just looking at the relationship between frequency and tension. So frequency is proportional to the square root of the tension. So they want the twice the frequency. So we want the frequency to double. Okay, so let's say, I don't know, if the frequency is 1, something like that. So if we want the frequency to double, so doubling this brings me to 2. In order to get this to equal 2, we would have to multiply it by 4, because that would give us the square root of 4, and the square root of 4 is 2. So to double the frequency, you need to multiply the tension by 4. That's because of that square root relationship. Question 6. When the tension in a stretch string is 40 newtons. Oh, what am I missing here? Did I miss half this question? It's in here anyway. So, okay, so here it is. Hang on. Done. Save. Okay. Homework. Sorry, now I'll just get rid of this and then add it in. Oh no, that's not what I want to do. Sorry. Bear with me. Picture. There you go. Add. Now, okay. So when the tension in a string is 40 newtons, its fundamental frequency is 260 hertz. Oh, so this is the same question. So, if you take the frequency from 40 up to 160, what are you doing there? You're multiplying it by 4, are you? 4 is 16. So you're multiplying it by 4. So then because it's the square root, this would double the frequency, which means the frequency for 160 would be 520 hertz. Yeah? So this goes up, so the tension goes up by a factor of 4. The frequency then increases only by the square root of 4, which means the frequency increases by 2. So we take our 260 that it started at and we double it. And that's where I got the 520. Now up to 200. So if it goes from 40 up to 200, what is that, by 5? Yeah, so that's multiplied by 5. So if the tension goes up by 5, the frequency goes up by the square root of 5, which means the frequency goes up by, I don't know, what's the square root of 5? It's a horrible number. It's like 2.236 and it goes on. So if I take my 260 and multiply it by the square root of 5, I get 581.4-ish, that's rounded. So the frequency is 581.4 hertz. Okay, so that is those solutions. You can let me know if you still have any issues with them.